Okay, so this is the beginning of Unit 3. The unit is called Solving Quadratic Equations. And this is going to be Lesson 1. The lesson is called Complex Numbers. Okay, so when you learn to count, you started by doing numbers like 1, 2, 3, 4, 5, and so on. Over time, your number system has grown. Now, in addition to numbers like 1, 2, and 3, you learn fractions like 1/2. You learned irrational numbers like the square root of 2. And now your number system is going to expand to include numbers such as the square root of -2. Okay? So here we go. This first definition is called the imaginary number I. The imaginary number I is defined as a number whose square is -1. Okay? An imaginary number is any number in the form a plus bi, where a and b are real numbers and b is not equal to 0. Okay? So what the imaginary number I is it's just a symbol that is used to allow us to do computations with the square roots of negatives. That's what I is, okay? It allows us to do mathematical problems that involve the square roots of negatives. Okay? So for the powers of I, we have I, which is defined as the square root of -1. Okay? Then we have I squared. So think about I squared. I squared equals I times I. So it equals the square root of -1 times the square root of -1, which equals -1. Then we have I cubed, which equals I squared times I. So it equals -1 times square root of -1, which is negative square root of -1. Then you have I to the 4th power, which if you think about it, I to the 4th power equals I squared times I squared. So it equals -1 times -1, which is 1. And now this process repeats. So I to the 5th power is the same as I to the 1st power, because if you think about it, it's I to the 4th power times I, so it's I to the 4th power times I. So the whole process just repeats. So we have I to the 5th, then we have I to the 6th, I to the 7th, I to the 8th, and these just repeat. So this one, I is the same as I to the 5th. I squared is the same as I to the 6th. I cubed is the same as I to the 7th. And I to the 4th is the same as I to the 8th. Now the two that you really got to make sure you know is you got to know this one and this one. Those are the two you definitely have to know. Okay? So those two you definitely have to memorize. We're going to use them throughout this lesson. Okay. Example 1. Simplify the square root of -10 using the imaginary number I. So for these problems, let me write it off to the side over here. If you remember back to Algebra 1 and geometry, whenever you want to simplify using simplify square roots, you're going to use perfect square numbers, like the square root of 1, because 1 is a perfect square because it equals 1 times 1. The square root of 4, 4 is a perfect number because it's 2 times 2. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. 6 times 6 is 36. 7 times 7 is 49. 8 times 8 is 64. I'm going to stop there because I'm running out of room a little bit. But if I say simplify the square root of -10, first you have to see if any of these numbers are factors of 10. Other than 1, because 1 always is. 4 is not a factor of 10 because 10 divided by 4 is a decimal. 9 is not a factor of 10 because 10 divided by 9 is a decimal. 16 is bigger than 10, so it's not a factor. Okay? So what we're going to do is I'm going to break this apart into the square root of negative 1 times the square root of 10. And the square root of negative 1 is going to be replaced with I. So when I simplify this, I have the square root of negative 1 times the square root of 10. The square root of negative 1 gets simplified into I. So this is the final answer right here. The I comes before the square root. Okay? Let's try another one. Simplify the square root of negative 45. Okay? So again, you're going to look at this list of numbers, see if any of these numbers are factors of 45. And 9 is, okay? First I'm going to take out the negative 1. And then I said 9 is a factor of 45. And 9 times 5 is 45. So I'm going to break apart the square root of negative 45 into this times this times this. Okay? The square root of 9 is 3. The square root of negative 1 is denoted with I. And the square root of 5 is going to stay. So this is my answer. Notice how I wrote that? I wrote the number, then the I, then the square root. Example 3 is similar to that. So, I mean, you might want to look back at the list of numbers on the previous page to see which one is a factor of 150. First, let me take out the negative 1. And if you go back to the first page really quick, I'm looking at this list of numbers right here. 25 is a factor of 150. Okay? So I'm going to rewrite 150 as square root of negative 1 still, square root of 25 times square root of 6, because 25 times 6 is 150. Okay? The square root of 25 is 5. The square root of negative 1 is going to be denoted with I, and the square root of 6 stays. Again, look at the way I wrote that. I wrote the number first, 5, then the I, then the square root. Okay. Another definition. Imaginary numbers and real numbers together make up the set of what's called complex numbers. Okay. A complex number can be written in the form a plus bi, where a and b are real numbers. Notice how you write it. It's a plus bi, not bi plus a. Okay, a plus bi. So the part with the I comes second. Example 4. Write the number, the square root of negative 9 plus 7, in the form a plus bi. Well, when I simplify the square root of negative 9, that becomes square root of negative 1 times square root of 9 plus 7. The square root of negative 1 is denoted with I. The square root of 3, the square root of 9 is 3. So this is 3i plus 7. And you have to write it in the form a plus bi. A plus bi. So I rewrite that as 7 plus 3i. Okay? That's called a complex number. Now let's do one a little trickier. Simplify the square root of negative 18 using that list of perfect square numbers in the first page. Okay? I can break 18 apart into, take out the square root of negative 1 again. I can break 18 down to 9 times 2. Because 9 is a perfect square number from that first page. 1, 4, 9, 16, 25, 9. This is all plus 6. The square root of 9 is 3. The square root of negative 1 is labeled with I. So 3I square root of 2 plus 6. And again, you're going to write it in the form A plus BI. So the final answer will be 6 plus 3I square root of 2. Now, this does come up in later lessons in this unit, so you have to understand how to do these problems. Okay. Example 6, simplify. What we're going to do is we are going to add these complex numbers. So all you're going to do is add the real parts, like the 5 and the negative 2. You're going to add those together, and you're going to add the imaginary parts, the parts with the i's. So I'll put those next to each other. Some people like to write them next to each other. So we've got 5, then minus 2, plus 7i, plus 6i. Combined like terms, 3 plus 13i. Again, it has to be in this form, a plus bi. So if you put 13i plus 3, that's not the right form. It has to be like this, 3 plus 13i. Same thing for number 7, but this time it's subtraction, so you have to distribute the negative sign. Okay? So this is going to be 8 plus 3i minus 2 minus 4i. You're distributing the negative sign. You're subtracting the 2 and the 4i. And now some people like to write the numbers next to each other, so I'll do that in case you like that, but you don't have to do this step. They like to write the i's next to each other, but you can skip that step if you want. Just combine like terms to get 6 minus 1i, or just 6 minus i. Example 8 is the same thing, so if you're at home watching this, you can, if you want to pause the video and try it on your own, you can. Distribute the negative sign there and there. Okay, distribute the negative sign. So it equals 3 plus 6i minus 4 minus negative 8i, which is plus 8i. And now combine like terms. If you want to put the numbers next to each other, that's fine. If you want to write the i's next to each other, that's fine. Otherwise, you can skip that step and go right to the final answer, which is negative 1 plus 14i. Okay, last page. We have 4 more problems. Example 9, simplify 5i times negative 4i. Okay. Well, 5 times negative 4 is negative 20. I times I is I squared. That's not the final answer because you can simplify I squared. Do you remember what that is from the first page? I squared equals negative 1. Remember how I said you had to know these two? You definitely have to know those two. So I squared is negative 1. Back to page 4. I squared is negative 1, so negative 20 times negative 1 is 20. Example 10, simplify 4i times 2 minus 5i. So distribute 8i minus 20i squared. And remember, I squared is negative 1, so this is really 8i minus 20 times negative 1. Negative 20 times negative 1 is positive 20, so it's 8i plus 20. That's not the final answer. Do you remember why? The final answer has to be in the form a plus bi, so it has to go 20 plus 8i for the final answer. What's the only thing better than distributing once? Distributing twice. So that's what we're going to do for example 11. We're going to distribute twice. Distribute the 2, so negative 6 plus 10i. And then distribute the 3i. Minus 9i. And then plus 15i squared. I squared is negative 1. So replace the I squared with negative 1, which gives you negative 15 right there. Finally, combine like terms and put it in the form a plus bi. So negative 6 minus 15 is negative 21 plus I. 10i minus 9i is plus I. Example 12 is the same thing as example 5. So if you understood, example 12 is the same as 11. So if you understood 11, try 12 on your own first. Maybe pause the video. Otherwise, we're going to distribute twice. Okay, so 24 minus 42i. Minus 20i plus 35i squared. Negative 5i times negative 7i is 35i squared. Okay, and remember, I squared equals negative 1. So the next step, I'll have 24 minus 42i minus 20i plus 35 times negative 1. And 35 times negative 1 is negative 35. Combine like terms. 24 minus 35 is negative 11. Combine the negative 42 and the negative 20 to negative 11 minus 62i. Okay. So that is the end of that lesson. That was Unit 3, Lesson 1. The lesson was called Complex Numbers. You definitely want to make sure you know these first two, I and I squared. And you really want to make sure you know this list of perfect square numbers. Preferably, you should have them memorized up to 225. We are going to go over that more in Lesson 3, I think, in this unit. So that's the end of that lesson. Complex numbers.